rendered it too. No, I didn't. So it's really a kind of a static dynamic form, which they really kind of started to fall in love with. I have a video of how this goes, so just stick with me. So then this is like the major update number 2. So you can already see if I just toggle back, how it was kind of an arbitrary sweep right here. And then we made these cuts. This is at the patient sightline, so it's optimized to be only open, so you're not getting glare, but you have sightlines out to the bay. And then, picking up the shading again. In this next one, we kept that same constraint at the sightline, but then what you're seeing is actually 2 grids. So the south facade and the east facade. And we kept that idea of the wadi, which is like the flowing, so it's a little bit less, one big swoop and it's kind of folded in. And each of these is the same prefabricated panels on both grids, but now I built the system to actually control each side independently. So here's a little bit closer look. You can see on the south side here, it's a smaller facade. That same rotation domain from 0 to 45, I can set that to 25 to 45 or something more. Or I could set this one to be a different range. So I could have the same system, same size, 2 different ranges of rotation, and now I basically built the algorithm to target each side of the building independently. So now instead of just being an arbitrary swoosh from Photoshop, it's actually setting up our sustainability team or our engineer team to say, you know what, we can tailor exactly how much perforation size you need, the exact size of the panels, how much rotation you're going to open up or close, and really get that performance that we were kind of lacking at that point. And again, just reiterating that same idea I just described. So trying to blend how we deal with perforation, and it didn't go there, but we wanted to optimize the next step for performance and sustainability. So then this is a video, and it's just about 2 minutes, but it pops the hood a little bit on what's going on. So on the upper left, you got rhino. On the bottom right is a really big grasshopper definition. You can see on the bottom right, there's 2 input curves, and I was dating them by when we were receiving design changes from our medical team. And basically, that's a straight extrusion, wasn't trying to beat around the bush, a continuous mesh, and then from there, there's a series of manipulations. So the big thing that happens is that we go from this complex facade to an unrolled flat facade, which looks very much like a rectangle. And it was intentionally designed that way. But now we can start to work between 3D and 2D and get some design opportunities when you're working in 2D. Because how do you draw when the curve is moving like this? So we unrolled it, we flattened it down, and then we started to break it up so that those cuts at the levels, where you have the sight lines, you start to slice at each floor plate. I can change that floor plate. Okay, we just increased the height to 13 feet or 15 feet or 12 feet. I just make a single change and it's updated instantly. The next part is actually, what I didn't show all the steps, but I marked off where those breaks were happening at the knuckles in the massing and set those transitions to transition exactly at the knuckles. So you can see we're starting to get that waveform transitioning from one level to the next level. And then now you can see I've remapped it from 2D up to 3D again. So it's going from flat, I map it, and I push it back up to the 3D facade. And that's going to continue to happen now. So anytime I make a change, that's getting pushed back. And now it's just rationalizing it down. So we've got the big surface, we're getting our subsurfaces, and now that I've made that division, I can control the south side versus the east side. And again, I would just simply do another curve on the north side and get both the north and the west side. And I'll just wait just one more minute because it kind of gets through. Stopped. Okay. And then the last little bit before, I'm not going to go all into the panels and all the rotations that's going on, but just getting to those subsurfaces and managing 2 sets of grids from a single input was a really big kind of breakthrough in some ways. So there's only like maybe 10 different parameters. So you can see the two different packages or groups of surfaces based on the east or the south facade. And then the only other step I go into is just how to sort of offset that, so you're actually getting a little slit and making it more constructible. And I'll just wait 2 seconds for that to finish. And you can see we're deriving every piece of geometry off of that single gesture. So now we're getting louvers that are extruding at the tops and bottoms of those cuts, and sort of trimming up that edge. So, and then from there, I'm not going to go into it, but you would subdivide each of those into the prefabricated panels, and you'd be done, basically. Again, this is just those two grids. Okay. And just some of the patient experience. We had a lot of different slides, but you got the views of the bays are very important. And then we also started down the path of solar analysis to optimize for that. Again, we didn't quite get all the way through that, but it's an opportunity where you can run the same surface, the same geometry, compare that against how it's performing from DaySim, energy analysis. This is the stuff that the US government's producing, so it's trusted by the government, it's their data, and we can leverage that. These are the different options that the other designers are working on. And then with the same definition, we could actually evolve it into how do we do with the interior. And so this is just a quick diagram that demonstrates that we basically repackaged the same algorithm and mapped it into how the interior feature wall was welcoming people in. So it was a cohesive design. And that's it in the background. Same paneling. It took down the facade, the offsets between panels, and then kind of tightened up for usability. So yeah, that's it. We have time for questions, and so I want to open it up if you guys want to ask us anything that was unclear or you're curious about, one more thing. I alluded to this at the beginning of my presentation. What I've seen as far as just computation, it's easier to get in with geometries to make these systems because you can see it. But the exciting part is that computational design reveals all the information, all the elements that are happening in your model like a database. So once you understand the logic and the flow, you can start to create surgical ways of accessing your information, accessing your models, and creating insights that can actually drive and reinform the design process. So it's not just making flashy stuff, even though that might sell, but it's actually driving business and value propositions and actually driving like legitimate, functional value for our clients beyond just simple, it's not simple, but you can apply it in geometry, but you can also apply it to information and how you access that and leverage it. So there's a lot of exciting stuff. I usually say facades are kind of the gateway into computation, but then from there it opens up a whole different world of working with your models. Questions? Right there?
You guys, what's your time frame on writing that draft topic script?
Sure.
Like
So the question was time frame. It's tough to put a number on it because that was like big project, big budget. I evolved the algorithm, it was the same one, for probably 4 months. And then before I got to the one that you saw at the end there. And they liked the premise from the beginning, but I had also, when I got the skills, we did some other stand-ups just to see what if we do vertical louvers, what if we start to be more creative with how we slice up. So it's the same two-dimensional, you go from 3D to 2D. I wrote those scripts in 2 days. So once you have the capability, you get comfortable with how to manage your data, your geometry, you can turn this stuff around really quick and just get a quick conceptual idea, and then it's the rationalization, all the coordination that really, there's a lot of effort in that as well. Question here?
How did you decide which iterations to render?
So did everybody hear the question? Which iterations to render? That was a team effort. The ones you saw were my track, We actually had 3 tracks that we brought forward. Again, big project, big budget, but yeah, I mean, they were empowering us as designers, and so, you know, the renderings at the end were actually done in-house. So the only renderings we outsourced were the very first ones you saw, with the dark brown and the arbitrary sweep. And then from there, we would have done another pass on which single iteration they would have picked. Other questions? Okay. Well, thank you all for coming. This has been really exciting.